Okay, so excited to be here. My name is Kent C. Dodds, and I have a lot to cover, so we're going to be pretty fast. But before we do that, I want to just really quickly talk about the thing that I'm working on full-time. It's epicweb.dev. Go take a look at it later. I'm not going to talk about it too much here. One thing that I want to do is wake you up. I don't want you to stand up or anything, because we don't have time for that, but I do want you to stretch as high as you can, and over one side, and over to the other. All right, thank you. Yeah, your brain needs blood flow. It's just science. So we're going to take advantage of that. This talk is going to be a bit of a journey through web development. It's also going to be forward-looking and also a bit of game. I want you to raise your hand if you've been in this industry for over 10 years. Holy smokes. Yeah, All Things Open brings a lot of you OGs into the forefront. It's awesome. So this will be a bit of a walk down memory lane for some of you, and maybe a little history lesson for others, and a bit of a game. And it's also not comprehensive. So those of you who've been doing this for a while, there's plenty of hand waving going on here. We don't have a lot of time to really get into the details. But if you do want to get into the details a little bit more, I have written about this on epicweb.dev, the web's next transition, so you can take a look at it there. OK, let's get started. So the web standards were standardized back over 25 years ago. So the web's been around for a while. Interestingly, not all of the web XHRs were standardized in 2016, which is hilarious to me because we were using it for over a decade before that. Yeah, there's something that says about our industry, at least for the front end. So since the very beginning, we've been able to build web applications because we've had links to be able to navigate between pages and forms to be able to submit data from the user back to the backend. So we've been able to build web apps for a long time. And there are various web architectures that we've kind of evolved into. So we started out with multi-page apps. We didn't call it that. That was just like building web apps, but MPAs. And then I made this thing up, PEMPAs, Progressively Enhanced Multi-Page Apps, so progressive enhancement. We'll talk about that a little bit. And right now, I would submit that the vast majority of web developers are working on SPAs, single-page apps. So that's kind of where we're at right now. I think that we're geared for a new transition. We're transitioning to something new, and I'm excited to tell you about it today. The game we're going to play is called Follow the Code. So we have different areas of code that we write for different use cases. Persistence, that'd be like your ORM or your hand-rolled ORM. Routing for taking a URL and finding the right code to call for that URL. The data fetching and data mutation for interacting with the ORM, and rendering logic for what HTML to generate based on the current state of the data. And then UI feedback to tell the user, hey, yeah, I recognize that you submitted this form. Networks are a thing, and so we have a pending state here somewhere. So let's start with MPAs. This is the basic architecture there. We have persistence, like everything is on the server. There were some people who were doing a little bit of JavaScript on the client, but for the most part, the application itself completely lived on the server. Architecturally, what this meant was when your user is requesting your document to load the page in the first place, the user enters the URL, and the browser is responsible for the UI feedback. So you don't write that code. The browser spins the favicon or whatever it does. And the routing on the back end will find the right data and then send that off to the rendering, and that will be sent to the client to render that HTML. And then when the user submits a form, we're going to do something actually a little bit similar. We're going to make a request. The browser actually knows how to serialize a form. A lot of us who joined in the last like 6 or 7 years know that forms are event.prevent default, and that's like, how do you do that? I don't know. So forms actually do know how to submit themselves. And so that will get routed through data mutation. It will update the persistence layer. And then it will send a redirect response unless you want to have a message that says, don't hit the back button. So it sends a redirect response, and then it does basically a GET request, so the same thing as a document request for the next page. And we'll have the latest up-to-date data from that data persistence layer. Cool, so that was it. And this actually gave us a really simple mental model for building web applications. People who have been around for a while are kind of lamenting how hard it is to build web apps today because it used to be so easy. Like, it was very easy to think about. Now, of course, there were a lot of complications with like browsers and stuff. Things were complicated in that way. But as far as how you thought about it, was all just like within the body of the request. And when the request is done, it's gone. Of course, there were complex things, like we had cookies and sessions. Sometimes you had to think about the complex workflows. But for the most part, really, really simple mental model. Also, it was the only way to do it, so that's why everybody did it that way, of course. But there were some pretty significant drawbacks here also. Full page refresh was not cool. Can you imagine if every time you favorited or liked a tweet, you got a full page refresh? No thanks. I don't want that. Nobody wanted that. It was not good. And we also didn't have as much control over the UI feedback. So for this reason, progressive enhancement showed up at around 2003 and came up with this idea that, hey, we can take a foundation of a functional app and enhance it with client-side JavaScript. So if you have that foundation of a functional app, you're going to keep all the same stuff you had from your MPA, but you're going to add stuff, both on the client and the server. You need to add it on the client to enhance it with not doing a full page refresh and stuff. But you also need to have server-side code to handle those AJAX requests that are going to show up at around 2006. So architecturally, the document request actually was quite the same because we had to keep that regular MPA full page render. But we also loaded JavaScript at the end so that we could enhance things based on whatever the user's browser supported, whether they supported AJAX or not. But we get this new capability, which is client-side navigations, where you hit a link and we prevent default. And so now we have client-side routing that's going to route things, and we have client-side data fetching that's going to make a call to the backend. And then the backend will have an API route, and it will call into data fetching and get the data and send it back so that we can render that up-to-date thing. This slide is actually quite important. We'll talk about it here in a second. It's specifically that rendering bit. Yeah, that's tough. Inline mutations, also a new thing that we could do with progressively enhanced multi-page apps. So now we can finally favorite a tweet without doing a full page refresh. So our user submits the form. We prevent default to avoid the full page refresh, and we use some data mutation code that we have on the client, send it back to our backend API server, and then we get the data back and we can render. And all the while, we have control over the UI feedback so that we can say, hey, here's a spinner. Or in Twitter's case, they do optimistic UI. So you click on the heart, it instantly turns red. And then they just hope that the request works out, and then they have to roll back if it doesn't. OK, and then redirect mutations. So this is like you're creating a GitHub issue, and you hit create, and it sends you to that issues page, right? So in this case, we're going to do a lot of the same things on the top as our inline mutation, but then we do a routing on the client and do our data fetching. So this is similar to the bottom half of the graph is actually similar to client-side navigation. OK, so with all of this said, the pros of progressively enhanced multi-page apps is that we don't have refreshes. That was like we accomplished our original goal. We wanted to improve user experience by eliminating full page refreshes. That's great. We also had UI feedback control, a lot more UI feedback control. You can now like favorite a bunch of tweets in a row, and you don't need to worry about like loading spinners being in the wrong place or whatever. So that was really nice. Unfortunately, we had a couple of problems that we introduced, new problems. Prevent default means that we're writing a lot more custom code, and I don't know about you, but I've noticed this correlation between how much code I have and how many bugs I have too. I know a correlation doesn't imply causation, but there's something there. And we're not as good at doing what the browser does as the browser is. The browser was really good at handling race conditions and form resubmissions and all of that stuff. And by and large, we struggled with that. This one's the biggest, though, code duplication. So let's say that you land on the GitHub issues page, and you have a couple of comments on there. So you have to have a template on the server for that server render to know what a GitHub comment looks like, right? But then I add a comment, and I hit submit, and then I'm not doing a full page refresh. So I've got to have the template on the client as well. So we have code duplication here in completely different languages, whether it's Ruby or Python or whatever it was that you had on the server, and then you've got it in JavaScript too. This was enormously painful. And often, we actually didn't have templates on the client. It was more like DOM manipulation. So the template was hiding in the imperative DOM manipulation code. It's just very, 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 very painful. Code organization is also a problem. Server and client interaction, also a bit of a problem. You're opening like 7 files in 2 or 3 repos. We still kind of have this problem sometimes. But so this motivated us to go to single-page apps. And basically what we did here was we said, you know what, that code duplication is dumb. I don't like it. It's stupid. So I'm just going to delete all of that duplicate code on the server side. We get rid of everything that's not an API route. We get rid of all the server-side rendering stuff. And now it's just an API route or an API server. Personally, as a front-end dev, I loved this because I just pointed my local environment to the staging server, and I didn't even have to run the backend on my machine. And I'm just like uploading files to a CDN or S3 bucket or something. Easiest deployment strategy in the world. I implemented like rollback, so like it was so easy to deploy this thing. I loved it. But we had some major problems. The document request for a SPA, single page app, is not great. So especially for anything dynamic. So the user enters a URL that goes to your CDN. That's going to have an index HTML that has like a body with a div that says ID equals root, and that's it. This was especially at the beginning. Now a lot of people are doing static site generation, improving this a bit, but for the most part, anything dynamic, you need to have some sort of loading state or something in there. And for a lot of us who are building apps on the web today, most of the stuff we're building is dynamic. And so the browser renders that, which is basically nothing. JavaScript loads, and now we can finally show our own UI feedback while we're going to get the rest of the code that we need and then the rest of the data. And then finally, when we get the data, we can render the images. And so now finally, we're going to get the images. This is our status quo. We all use apps like this. I'm not going to call anybody out right now, but your banking website, a certain site where you go watch videos, YouTube, I don't know. And so we've got problems. Like this, I don't know why it's okay, but it's not. It's not okay. The client-side navigation didn't change from Pempa. The inline mutation request didn't change from Pempa. And the redirect mutation request didn't change from Pempa. From progressively enhanced multi-page apps. I know that the acronyms might be confusing. So the only thing we changed was to make one of these worse. Why did we do that? We did it for a reason. It wasn't just for kicks. It's because the code duplication was so bad. We didn't like that. I didn't like that. So this was way better from a developer experience standpoint. But it was worse for the user experience. So we transitioned from MPA to Pempa for the user. We wanted to make the user's experience better. Transitioned from a Pempa to a SPA for the developer. We made the user experience worse. We still have most of the Pempa problems. Now we have a bundle size problem. We have waterfalls, as I described. We've got runtime performance issues because we have all this JavaScript. I mean, I realize that this device in my pocket has more power than what we sent people to the moon with. But I don't know. Like, it still seems to have problems loading certain websites. So we had some problems. And then state management became a thing. And you just go over to NPM and look up how many libraries there are to solve that problem. That's your evidence that state management is a really difficult problem. And this is, I would argue, the reason why we believe, or folks who've been doing web for a long time, lament how hard it is to build a web app these days. Because state management, really, really tough. So I'm ready for a transition. I think we need something better. And I'm excited. Like, I'm outrageously excited. I am screaming at your face excited about this next transition. The transition, I'm calling it progressively enhanced single-page apps. It rhymes with Vespa. It's a PESPA. How many of you have watched Luca? I asked this question in crowds, and I'm surprised how few of you raise your hands, because it's a great movie. So go watch Luca. Let's talk about the architecture of a PESPA. In a PESPA, you're sharing code on both the client and the server. This has been tried before, and it didn't work out super great, but it's working out great now. We'll talk about this a little bit more. So now your routing code, your data fetching, data mutation, and rendering can be shared across the client and the server. The document request looks just like a Pempa, exactly like a Pempa. The client-side navigation, very similar to a Pempa, except now we're not duplicating code between the client and the server. We're using the same code between the two. The inline mutation request, very similar architecture, and the router has a lot more to say about how things get routed to the right code on both the client and the server. It's not super important that you understand or take pictures of all these slides, by the way. I've got all these charts in the blog post that you'll see at the end here. And then the redirect mutation request also. Client and server share a lot of the code right here. And a lot of this is managed by our router. And ultimately, that rendering code, that code is actually also shared on the client and the server. But when we're just doing the SPA piece of this, that's only going to run on the client. So let's talk about some of the pros. We have the simple mental model again. When you're working in a PESPA architecture, it feels like you're working in an MPA architecture. It really does. It just feels that simple. We don't have the full page refresh. We have our UI feedback control. Our browser, it feels like you're just working with the browser the way that it was intended, and we'll actually look at some code to kind of see what that feels like. And we got rid of the code duplication of PEMPAs, progressively enhanced multi-page apps. We also reduced client-side JavaScript because we're just moving as much of our stuff over to the server as we can. Most of our business logic and everything, the only stuff that's client-side only is going to be progressive enhancement stuff, which is pretty simple. And we got rid of waterfalls because it's all server rendered again, hooray, and no application state management. You can't have application state management if you are focused on progressive enhancement because it has to work without JavaScript. So if your app requires application state management, then it's not going to work without JavaScript. That's not a PESPA. Of course, there is state that happens in the client, like whether this dropdown or this modal is open or whatever. There's going to be state. But that state's easy. It's the application state management that's really hard. Cons are difficult because when you start dating somebody new, you don't know all of their weak points. And then eventually you're dating them for a while and you realize that they do have weak points, but you love them anyway because we all do. And we're all struggling. So I want to talk about a couple that people have brought up, but we will definitely discover more. So one is that it requires servers. For me, when I was doing a spa, I just loved sending stuff to a CDN and forgetting about it. But now I have to worry about a server. Most applications have to worry about a server at some point. It's just that now the devs working on the front end of the web app have to think about this too. So yeah, there's that. Server cost is also typically the people who are worried about this are like, I can just put it on a CDN, I don't need to worry about it. If that's the type of site that you have, then you can actually use cache headers that will tell the CDN to cache things, and you have the exact same type of architecture anyway. And so I don't see that as a huge issue. But also, Cloudflare is going to give us 1 million requests for 15 cents. So I don't know what to tell you. Infrastructure is a lot cheaper than it used to be. Also, universal code, you've got to make sure that your code runs in both places. And then, of course, we will discover more issues as this goes on. But I'm very, very excited that we're making a transition that is better not only for UX, but also for DX. This is great. Makes things a lot simpler. An example implementation of this, Remix. So I was a co-founder and director of developer experience at Remix. Remix was announced yesterday that it was purchased by Shopify, so that's exciting. I am no longer at Remix, working full-time on Epic Web. But I want to talk about Remix a little bit specifically, how Remix does this. So this is an example of a Remix route. So your loader runs only on the server. So you can use private keys. You don't worry about cores. You can talk to a database directly, whatever you want to do in here. And then that data gets sent over to the UI code via use loader data. So Remix uses React right now. In the future, you'll be able to use other UI libraries, whatever you want. If you're like, ooh, it uses React, I don't like React, I promise, anything that you don't like about React is not really a problem in Remix. React just feels like a template solution, which is awesome. And React actually can do a lot of really cool things. I'd love to talk to you about it later. But we bring in our data, we render out our data, and then we can also render out a form. And it's just a regular form. This is why I say it feels like an MPA. So you just have this form component, and Remix progressively enhances it so you avoid the full page refresh. And we also can progressively enhance this by hooking into the pending state of the form so we can show some sort of pending UI for our users. And then when that finally is submitted, that's going to go to our backend code, which is in the exact same file. And so we're like, here's where they submit it. It goes right here. It's amazing. And so now we can do all the server stuff that we need to do, validation, anything that you need to do to create the data that you're going to create, whatever it is. And then we can send that data back to our UI if we have some sort of error, and we can display the errors. All in a single file that magically works in a wonderful way, where this code is shared. So that UI code is shared both between the client and the server, and Remix manages making sure that form submissions go to the right place and GET requests make it to the right place. And it's outrageously fast. Very, very cool. So I love things like this where somebody's like, oh, I was just building my app and having a really great DX, and then I accidentally stumbled into an awesome UX. I didn't even try the Lighthouse score, and then when I decided to try it on an authenticated, most expensive page with no caching, and I got 100 performance score. I'm sure that was not on mobile. Maybe it was. But excellent. Like, awesome DX and accidentally awesome UX, sign me up. I'm super into this. So I'm finished. The last link on the resources slide here is a link to a GitHub repo where I implemented all of the architectures, the same app in all the architectures, so you can compare and see the differences. And then this is the blog post where I kind of explain this a little bit in deeper, more detail. I just have one last thing to say to you all, and it's this. You belong here. Thank you so much.